Good evening, guys. How are you doing today? So we continue from where we stopped. Though we talked about user-defined in the previous lectures, we want to also incorporate it with file handling in C. Now let's see, we've seen a sample of user-defined structures. We've seen how you can also incorporate it with normal values and also with pointers. Now we also want to see how we can also integrate it with what? With file system. So now let's see a sample of it. We have struct here. We discussed about structure before. So we create a struct called students. The student ID takes a 10-digit number. Then we have the first name taking the 1050 character, 10 bytes, and last name as well 10 bytes or 50 bytes. So we have the float also GPA taking 4 bytes. Then we have it making a total sum of the total sum is 10, this is 100, 110, 114, 113, 114. So we have then we can also create the structure here, the object of the structures, just as we did in the previous lectures. So remember, the reason why we're using struct here is because the kind of structure we use is not the Typedef zone. So that's the reason why we have struct in front of it here. Then we copy, we now assign value to them. Then this is the ID of the student. Imagine, these strings, I've also explained the reason why we use string copy for character string manipulation. Unlike integer that we just, or floating points, we just assign the value straight in the previous lecture as well. So we'll copy the string for immutability purposes. We use the string copy to copy the string, give the value, and this is is destination. We use this object of string one here, declare here, to associate it with all the variables, the variable declared inside the structures. Okay. We said before that structure enables us to structure our codes, to modularize our code, to have multiple types. But in case our primitive types enable us for only one single type at once at a time. But the structure can combine multiple types together. And let's see a real life example. A university student information system uses structures to manage comprehensive data for his students. We want to have GPA, we also want to pay. Sometimes you give maybe your payment portal as well. You can also have it such that you have your name, your registration number, and your department, and so as many information needed. So we can incorporate it inside. Then we can also use structures as pointer, as we discussed in our previous lecture. Please, you can go through them, and in case you need some dynamic memory allocations, so you can easily also use it. We'll look at it in the first lectures. Then let's look at also pass structure to functions, as we also seen in the previous lecture as well. But here we are using structure with file. We are using structure with file here. This is the one also we discussed the previous lectures. Then now, yes, we begin here now. We have file. File as compared to a console level, enable for persistent storage, just like database. And at console level, as input stream and output streams, once we enter them and we close the terminal, we don't get access to those information anymore. They are lost forever. So until we recompile, we give the information again, we get our result back as well. Then now, to this enable let's file enable program to read from and write to this C program also enables to write to file and read from a file. Majority of the images by some engineers or developers store their images inside a file. File system, they both use database and file system for data persistency. Then let's look the concept of streams and file pointer. Yeah. File is a pointer, so an abstraction representing the flow of data from a file. So treat all I/O as stream interactions as well. So file pointer, can you see? This is the type here. We want to create a file, we use file, then we give the variable name as a pointer to a file. I'm going to see a sample of it. Let's see the real world. Think of a stream as pi. a stream as pipe of water, maybe a pipe of fuel. Data flows from the file through the pipe to you. Now we are talking about computations. Data flows from the file through the pipe to your program, like input, or from your program through the pipe to the file output. That means when you receive in data or stand from the user, then you output the result back again through the same process. Now, the file is like the handle or valve you use to control and access this file. Then, before you can read to a file or write to a file, you first need to open it. There's a function called open. This function is very common in every programming language. Even in Python, we make use of open. We also have in C, in Java, in C++, you use what you open the file. Before you know, the location must exist where you are storing the file. Before you make use of, before you write to them, or before you read from them, or before you append to the previous data. Imagine if you are writing to data and you don't append, maybe if you run your program again to overwrite what you have, but you can also see append from it, for it. You can also write binary, you can also read binary. I will show you some of this mode of which this thing can be done as we proceed. Then the F open, can you see this is the file name? You can also include the path in alongside with it. File name here, you can put the path here. If you don't specify the path, you're going to store in the same directory where your code resides. But if you specify the path, it's going to be stored in the path with the file name together with it. This is the mode. The mode can be read, write, append, write byte, read byte. So depending on the operation we want to do. So we also need to close the file so that we can work with allow access people, other people, or other resources to access it. As well, anything we open, we close it. Also, we use the close functions and pass in the file object into it. So then this is how we create a file. Here, we create a file here, log this, application.log. This is A for appending. Then if log file equal to null, then the P error, the error open the log file, then F close for closing the file. So now we are opening and closing file using the F open to open, F close to close it. Let's see a sample of what the real world. A web server application opens a log file, access.log on startup to record incoming requests. It also opens configuration files. If you are a computer student or you're a developer, you know what I'm talking about. Server.conf, config. So to read settings for me, crucially, the server closes these files when it's shut down to ensure data integrity and free system resources from the server. You can also create your own files as well from error. Maybe you have some engine servers. Maybe you have, for example, like Nginx or Apache servers. Some of these also log their errors in a file, of which you have issue with your configuration. You can look at these error files that is being configured by the developers. Then let's look ahead. Let's see some of this mode. I told you the other time you can read. Just specify the R, or specify W inside the codes, or R plus to read and update. Can you see some of this mode you can use in C programming language? Then you can also read the binary, write bytes. Let's see a sample of real-world example of it. R means in test mode, reading the configuration file, setting.ini. Some of these ini files are found in Windows applications with human readable key value pairs. Test mode, A, for appending maybe to a CSV, comma separated value, let's to CSV. We also do the same thing with all these formats you are seeing here. Formatted file, let's see how we can format the file as well. In our normal writing and AIO operations, we use printf to print and to print to the console, or to output the information to the console. But here, to write to the file, we use fprintf to write to the file. We can also use fscanf to receive data information from the user. So this function works like printf and scanf, but operates on file stream. This one operates on file streams also on file same as well. Fprintf file this, because this. You're going to see, I'm going to demonstrate a sample of this. So this, maybe you allow this one to be scary to you. Maybe it is a pointer, this is a pointer, this is parameter argument. So then we also read from, we also use f is taking in what these are the argument we need to supply. Taking the file object, taking the character we want to read, want to write as well. Maybe the character you said in format, the format you want to write it. Then the later one you supply the information you want to write to read. The same thing as well here. The file object, the formatted, the way you want to format it. Then you read from the console. Then we can also we create a file object and we open it. We firstly ensure that we open it. Here we ensure is employee data file not equal to null. Is this resources location? No, I told you the other time that we can also get the path to this side to the employee. Is it available? If it's not, if it's available, if it's not, no. Okay, that means it's available. Then we can write to data. Then we can, these are formats to take a string of data. This one takes a string of data. We also take a string of data. So that it takes in what 2 decimal place of floating point variables stored in this place. Then we can get Alice Wonder. Therefore, it's taking the employee ID. And so you store the employee ID, store the name, the salary as well. You can also read from a file. You can read from a file. Then if this also force this is just the T for something, you create if we use the R mode. Here we use the W mode to what? To write to the file. We check if it's not known, then we read from it. So we read and we display the results. So let's see a sample of this information I can do. An index generation program uses the fprintf to write customer details and attachments leads to structures, human readable text file. A data analysis tool might use fscanf to read numerical data from a formatted text file exported by another applications. So then we can also see character and block file IO. Read text, then string IO. You can see block binary IO. You can see this. You can use fread, fwrite. You can also write to binary applications. You can see a sample of them here. You can also do some of them. I also demonstrate some of them. I'm going to get information from the user. I also go to write to the user as well. So now let's see. Then we read from it. Then let's see a sample. Okay. Then we can see. Let's create a simple example. You can go through this. You can go through this slide yourself. Slice social containing pointer directly is generally on sale. Pointer addresses are memory located. Specific can become invalid when read back in different program execution or another machine. You need to handle such structure by saving the data they point to, not to the pointer addresses themselves. You can see fseek, ftels. You can use some of these functions. Fseek to locate some position. You can see fseek, ftels for your own practical applications. In case you are working with file applications, you need to use some of this command to ease our work. Then, thank you very much. Let's firstly open our Visual Studio Code and let's demonstrate some of this example. And let's firstly write. Let me just call open. For example, okay, I think I have P10 here. P10 here. Let me just create a file called maybe sample.c. Then we include our text file, stdio. Then we also our string. Then we want to string.h. Let's create a short Typedef for student. Just get the information from the student and let's store it inside int id. Then just ID, then we have car, just full name, car name, just make it 100 of character. Then we give it a name here, user. Then we have it this way. Now let's create a function. Let's first create a function prototype. A function prototype or a function, a defined function prototype, so that will allow me to be in the middle. Maybe create user info. It's not taking any parameter. Int main. Then we return 0. Then we now create this is our first prototype here. We now create the real function here now. The same way, same function signature is the info. Or if we don't create this, create the other one, the function is not defined. If the function is not defined, let's create the object of this user now. This user here, user. Then we have the user able to access all these variables. Then we have file. This is the file object. F is a pointer. Remember, F. Let's open it. Let's see. It will store inside this directory as well. It will store inside this directory. If you also want it to store outside here, we can also specify by just saying, okay, let's by change to outside, move outside a little bit. Then you now call it lba.txt, for example. Then we write A to append any information to that file. Then we have this now working. Then if we write now, if I come to this place now, and just okay, clear call the function, create user info. Let's compile this. Where we're going to see a file called that in here, not even inside the path we specify. Let's just create that cd d10. Okay, compile. Okay, sorry. Is sample.c. Say it's a f open, say p open. So it's f open. It's f open, not p open. So we have it here. Then I can run my app.p. I see. You can see our fba.txt here. There is nothing inside this .txt. And you see, it's already it's working correctly now. But now let's get information from the user and let's stop it directly to the file that we just created. Okay, printf. Enter that user information, that user ID. Then you just get the user information. You just use scanf, for example. Scanf is taken in integer. Then we get in the integer from the user.id. We get this, we use this object, user object, to call the ID and assign the value to it. It's an integer, declare integer here. Now let's go ahead. Now let's clear the character, the new line at the end of the scanf. So we clear it. Now let's printf again. Let's get the username. Enter the full name. Then after that, sorry. Then we use our what? Let's use our fget. Fget to get the file name. Let's see what is showing us here. The function is showing us the string, the size, and the other streams, and the std input stream. That means it's showing us what we want to get. That is user.name. The size is what? Size of number of characters that we have. What is the size of what? Of user.name. Then we get std input. standard input. Then we do this one here. But before this, let's firstly check whether our file is f, whether f is not equal to what? No. Then I paste it here back. So let's check whether it is not null. Then s fprintf unable to open file, unable to open the file. So then we move send. Is there any error here? Unable to open printf. Get display message unable to open the file. Then here now we store the message. Let's remove any string 0. Let's use user.name. Remove any .0 new line at the back of the string as well. Let's remove string C pan, string cell C pan span, and it's a function. It's a function. Yes, it's a function that is taking in what is user dot name, and look at this new line turning equal to what? 0. I just see any error there. Then let's write down to the file. Let's write the information. Add the information to the file. Then we now use our fwrite or our fprintf to write this information. Let's see the object. Is given the file object, specify the file object and the format. So file object is f. The format is our ID %d is per integer, then name. You can do as many as that % a string. Then since when you specifying this format here, let's now give the value to store. User dot what? ID user dot name. That you should not forget to close fclose to close the file f after the end. Now let's compile this now. We should be able to see, you should be able to get the information from the console to yes. Now let's enter user ID 101. I'm having called done. Cell call 40. It's get car. Okay, I'll get the address of this. Set segmentation fault core. Coming. That is 101. I'm getting down maybe a software favor taming. Then we have it here now. So it's done successfully. Let's check this now. You can see we have favor taming here. But one thing is that you can also still run it again and add another person 102. Maybe your name is Tayo Femi, for example. Then we have the information. We should have the information here. We also have what Tayo Femi added here. So unlike if we change this back to, by changing to right, the models, it should erase everything. It will erase what we have initially. And maybe 104. Then this is Isaac. as a meeting. Then you should have it in. And see, it actually erase everything that you have. So thank you very much. Please like, share, subscribe, and have a wonderful day.